Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 6.6 parallel lines. Hopefully you remember some things about parallel lines so that we can use this information to write new equations. Two lines are considered parallel if they never cross. That means these lines can go on forever and ever and ever. They will never touch, they'll never cross, they'll never get anywhere or any closer to one another. The equation of the line that is shown already on our graph is y equals 1/2 x minus 3. If you notice that b value is right here at 0, -3. Another way to write that, that's slope-intercept form. Another way to write that is y minus 1 is equal to 1/2 times x minus 8, which is our point slope form. What we need to do is make a new line that is parallel to the first. So what I'm going to do is I'm going to change our b value to 0, 0. Okay? What I want you to realize is if I change my b value, the change from -3 to 0, I went up 3, right? Well, if these lines will never cross or get closer to one another, then all I have to do is go to each point on my original line and go up 3. So 1, 2, 3, be a new point. Go up 3, 1, 2, 3, there's a new point. And now I have my new line already, okay? Just connect my points. Hopefully you guys have a straight edge to make your line a little better than what mine is. All right. So now we have our two parallel lines. Our job now is to write the equation in both slope-intercept form and point-slope form of our new line. Okay? Well, y equals, what is my slope of my new line? If I start at 0, 0, go down 2, it'd be -2 over 1, 2, 3, 4. My new slope would have been -2, -4. Well, if I simplify -2, -4, it turns into 1/2. Same slope as our original. So 1/2 x. What is my b value? In this case, my b value of my new red line is going to be 0, so I'll just add 0. All right, so that is my equation in slope-intercept form. Now, to write it in slope or point-slope form, I need to use one of my points. Let's use this point here, which would be +8, +4. If I use +8, +4, it would be y minus 4 is equal to 1/2 x minus 8. And I have written a new point in point-slope form. I've written my new equation in point-slope form. Okay? What do you notice about our two equations of our two lines? What is the same about both? Well, if two lines are parallel, then their slopes are identical. Whoops. Keep messing that up. I'm sorry. Identical. Their two slopes will be identical. Does that make sense? Well, let's think about the movement that slope makes happen. It would be the same rise over run. Well, if they had the same rise over run, that would mean that they would never end up touching each other or crossing. They're going to go in an exact same motion all the way through, right? So that does make sense that parallel lines should have the same slope. Now, here's a reminder that point-slope form is y minus y1 is equal to m, or my slope, times x minus x1. So what we need to find out is, are these two lines parallel? Well, what I could do is I can rewrite these into, standard form wouldn't really get us anywhere because that doesn't tell us our slope. So I either could put these equations into point-slope form or slope-intercept form. Being that this first equation here is already in slope-intercept form, let's just change our standard form equation into slope-intercept form. So if I subtract 2x from both sides, I end up with 6y is equal to -2x plus 12. In order to get it into slope-intercept form, I need to solve for y. So if I divide by 6 all the way through, I end up with y equals -2 over 6 would simplify. They're both divisible by 2, so it would simplify into -1 over 3x. 12 divided by 6 would be +2. Are our slopes identical? Well, my slope for my new equation is negative 1 over 3. My slope for my original was negative 1 over 3. So yes, they are. Okay, on to problem number 2. Again, my second line here, my second equation, is in slope-intercept form. So let's take our standard form into slope-intercept form. If I were to work through this, I need to solve for my y, so I'd add 6x first. So 8y equals 6x minus 24. Divide by 8 to solve for y. So y would equal 6 over 8. Both 6 and 8 are divisible by 2. That would lead us to 3 over 4x. Negative 24 divided by 8 would be negative 3. Are these slopes identical? This is positive 3 over 4. This is negative 3 over 4. They are not identical because the original slope-intercept form line was negative. Our new slope-intercept form line was positive. So they would not be identical. They would end up crossing at some point. Okay? Example 2. Write an equation for the line that contains the given point and is parallel to the given line. Write your final answer in point-slope form. Just telling us to write it in point-slope form. So the first thing I need to find is my slope. Remember, my slope is always attached to my x. So my slope in this problem is 3. Now I need to use the point that they have given us and my slope to write it in point-slope form. Point-slope form is y minus y1, which would be negative 6, is equal to my slope times x minus x1, which would be 2. Is this in simplest form? Well, right now it is not because I have minus a negative, which is the same thing as y plus 6 is equal to 3 times x minus 2. And now I am done. That is my answer in point-slope form. Okay. On to problem 4. What's my slope? So it's attached to the x, so 3 over 5 is my slope. I have to write this in point-slope form, so y minus y1 would be positive 1 is equal to 3 over 5. X minus x1, in this case it would be 5. So it is written in point-slope form. I am good. All right. Moving on to the back. Example 2. Write an equation for the line that contains the given point and is parallel to the given line. Write your final answer in slope-intercept form. Well, because I'm going to have a point and a slope, I'm originally going to have to write this in point-slope form and then have to turn it into slope-intercept form. Okay? It's not that hard of a process. I just have to solve for y at the end. So originally, you're doing the exact same process as you did on the front. My slope's negative 6. The point I must use is 0, 0. So to write it in slope-intercept form would be y minus 0 is equal to negative 6 times x minus 0. Because my y1 is 0, my x1 is 0. Okay. Since it's y minus 0, I can just drop the 0. This would be minus 6. Since it's x minus 0 as well, I can just drop my 0, so it would be negative 6x. The other thing you need to realize is if you need to take an equation from point-slope form to slope-intercept form, we're going to go ahead and distribute that negative 6. Well, if I have negative 6 times x, I end up with negative 6x. Negative 6 times negative 0 would be 0, so I didn't have to write it. That would be my answer in slope-intercept form. On to 6. This one's a little trickier. It just has y equals 8. Well, if y equals 8, remember that my slope, anytime I have y equals, will be 0. Okay? Now I need to write it in point-slope form, so y minus y1 is 1 is equal to 0 times x minus x1 is 5, so x minus 5. If I distribute this 0 in, I would end up with y minus 1 is equal to 0 times x is 0, 0 times negative 5 is 0. So it's just equal to 0. Add 1 to both sides. Y would equal 1, and we are good. Does that make sense that a y equals would be parallel to another y equals line? It does, because when I have a y equals line, it's a straight horizontal line. In order to make a line parallel to that, it would also need to be a straight horizontal line. Okay? On to problem 7. My slope is 1/2. So you can either just write out what your slope is, like we were above when it gave us that option, or you could go straight into point slope form. It's completely up to you. Point slope form would be y minus 1, because my y1 is 1, times 1/2 times x. My x1 is 1 as well, so it'd be x minus 1. Remember to distribute the the 1/2. So y minus 1 would equal 1/2 x. 1/2 times negative 1 would be negative 1/2. Now I need to add my 1 to get the y by itself, so y would equal 1/2 x. Negative 1/2 plus 1 would be positive 1/2, and I am done. Okay. On to problem number 8. Again, I have a slope of negative 2 over 3. I'm going to show you how to go straight to my equation without writing my slope down first. It really doesn't change anything. You would just have to be able to recognize your slope, which is this negative 2 over 3. So in point slope form, it would be y minus y1, which is 1. Then I use my slope, which is negative 2 over 3, times x minus x1, which is 9. Okay. If I distribute the negative 2 over 3, be y minus 1 is equal to negative 2 over 3x. What is negative 9 times negative 2 over 3? You don't have to write this down because you could always use your calculator, but negative 9 over 1 times negative 2 over 3 would equal positive 18, because negative 9 times negative 2 is 18. 1 times 3 is 3. 18 over 3 would end up being 6. So this would be plus 6. Okay. Now to put it in slope-intercept form, I need to get y by itself. So I'll add 1. Y equals negative 2 over 3x plus 7. And I am done. All right. The most important thing to remember from this note sheet is what are parallel lines. They are two lines that will never cross, which means that their slopes will be identical. There are a few different ways that you could write those equations. You could write an equation in slope-intercept form, and you could write that equation in point-slope form. Just realize how I could go from point-slope form to slope-intercept form. I would just have to distribute my my slope and then solve for y, and I would have my slope-intercept form. If you have any questions over this note sheet, please make sure you bring them to me tomorrow before class or during class right before we get started. We'll get you fixed up. Thank you very much for watching this video, and have a great day.